స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్ సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3 గంటల 30 నిమిషాల నుండి సాయంత్రం 5 గంటల 30 నిమిషాల వరకు, తిరిగి సాయంత్రం 6 గంటల నుంచి 7 గంటల వరకు మీ V3 న్యూస్ ఛానల్లో, V3 న్యూస్ యాప్లో, V3 న్యూస్ యూట్యూబ్లో ప్రసారం అవుతుంది. యూట్యూబ్లో V3 న్యూస్ ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి. అలాగే V3 న్యూస్ యాప్ను మీ మొబైల్స్లో ఇన్స్టాల్ చేసుకోండి. దశాబ్దాల అనుభవం గల ఫ్యాకల్టీలు అందించే క్లాసులను వినండి, సద్వినియోగం చేసుకోండి, విజేతలు కండి. ఫ్యాకల్టీల వివరాలు: మ్యాథ్స్ బాదం శ్రీనివాస్, కెమిస్ట్రీ రవీంద్రనాథ్, ఫిజిక్స్ ఆసిఫ్, బాటనీ మిట్టపల్లి రామ్నాథ్, జువాలజీ CH కొండలరావు. V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్.
Good afternoon, students. Today we will see some important reactions in hydrocarbons and related examples. First we will see in preparation methods of alkanes, the very important one is decarboxylation. Don't think that it is easy. There may be some tricky questions based on this decarboxylation also. You know that decarboxylation is heating of sodium salt of a carboxylic acid with soda lime. In this alkanes are formed. Soda lime is NaOH plus CaO on heating. So finally we will get alkane Na2CO3. This one. Now if you take CH3COONA on heating with soda lime, just we get methane. You remove Na2CO3 from this, you add hydrogen to this one, so it becomes methane. This is sodium acetate. Similarly, if we take sodium benzoate, we get benzene, C6H6 plus Na2CO3, benzene. Suppose a direct question is given, what is product in heating of sodium acetate, you can answer. If it is asked, what is the rate of decarboxylation of sodium propanoate and sodium ethanoate? Sodium propanoate is CH3CH2 COONA, sodium ethanoate is this one. This is sodium propanoate. And this one sodium ethanoate, 2 carbon carboxylic acid, so sodium ethanoate. Now tell me, what is the rate of decarboxylation? Which one undergoes decarboxylation in higher rate? How to see? How to see? For that you have to know what is the intermediate formed in decarboxylation. And according to one of the mechanisms in decarboxylation, carbene ion is formed as an intermediate. Carbene ion. Okay, I will take this one, RCOONA. Here what is there? NaOH from base, that is OH minus. This OH minus attacks at this, then it is converted into RCO minus OHONA. And next step, this bond is broken. This electron pair forms a bond here, then this bond is broken, so it becomes R minus plus NaHCO3. Finally, this NaHCO3 is converted into sodium carbonate. So what is this carbanion intermediate? Now to find out what is rate of decarboxylation of different carboxylic acids, you have to know the stability of carbanions. The carboxylic acid which forms a more stable carbanion readily undergoes decarboxylation, that is rate of decarboxylation will be more. Now tell me, if you take sodium propionate and sodium ethanoate here, for this what is the carbanion formed? CH3CH2 minus. Sodium ethanoate, what is the carbanion formed? Sodium ethanoate. Take break it here and take carbanion from alkyl group. This is ethyl carbanion. Next one is methyl carbanion. Yesterday we discussed that the stability of carbanions, alkyl carbanions decreases with the increase of plus I effect. Here there is more plus I, here no plus I effect. Then which is less stable carbanion? This is less stable. Then what is rate of decarboxylation? CH3CH2COONA is less than CH3COONA. Like this you have to see. Many people think that decarboxylation, what is there? Just breaking of this bond and writing hydrogen to this one. But in higher levels there may be a question related to rate of decarboxylation. So this is rate of decarboxylation. Like this you can compare rate of decarboxylation of many examples based on stability of intermediate carbanion formed. That is. Now we will take one more example related to this decarboxylation, rate of decarboxylation. Let CCl3COOH, CCl2CH, this one COH, ClCH2COOH, CH3COOH. This is a trichloroacetic acid. You know what is acetic acid? CH3COOH is acetic acid, in that all the chlorines are replaced by hydrogens are replaced by chlorines, trichloroacetic acid. Similarly, this is dichloroacetic acid, this is monochloro or simply chloroacetic acid, and this one is acetic acid. Then what is the rate of decarboxylation? How to see? You have to see what are the intermediate carbanions formed. What is the intermediate carbanion formed from this? This one. Here CHCl, Cl minus. Here CH2, Cl minus. Here CH3 minus. Already we discussed that minus I groups increase stability of carbanions. More the number of minus I groups, more is the stability of carbanion. So this is more minus I effect, then more is stability. More is stability of the intermediate formed means the rate of decarboxylation is more. Then what is the order of rate of decarboxylation? Rate decreases, this one. Okay. Now we will take another important concept in this hydrocarbons, that is Kolb's electrolysis. So Kolb's electrolysis is also used for preparation of hydrocarbons from aqueous solutions of sodium salts of or potassium salts of carboxylic acids. Let RCONA is a sodium carboxylate in aqueous solution. Electrolysis of this one. Here you break and combine these two alkyl groups, it gives RR, CO2 plus here hydrogen gas is liberated and here NaOH is formed. Then this reaction takes place through formation of what intermediate? That you have to know. This reaction takes place through formation of a free radical intermediate. We say mechanism, okay, already you might be knowing, but this is important in entrance point of view. In organic reactions based on intermediates and their stabilities. Okay, so here if you take RCOONA, it ionizes to give RC double bond O minus plus Na plus. Now at anode, this RC double bond O minus, this loses an electron, RC double bond O. Now this oxygen gets one unpaired electron, plus electron. Then next step, one electron from this carbon and alkyl group is transferred like this, and this electron forms a bond with this one. Then it becomes alkyl free radical plus CO2. The next step, two alkyl groups combine to give an alkane, this one. So what is the intermediate formed here? A free radical intermediate. Free radical, this is formed. Then if you take at cathode, from water, from H plus of water, here hydrogen gas is liberated. That is different. Now coming to examples related to this one, how to write direct products. Not only simple examples, some different examples also you will see. First, okay, CH3CH2COONA. Here also there is a removal of COO group. That is why this Kolb's electrolysis is also a type of decarboxylation. Even you may be asked a question, which of the following is a decarboxylation, by giving a RCOONA with soda lime, RCOONA aqueous solution electrolysis. Then many people think that this is only decarboxylation, but this is also a decarboxylation reaction. Then if you take this one, how to write a direct product? You take 2 moles of this one, break it here, combine 2 alkyl groups, CH3CH2 and another alkyl group CH2CH3 plus here it is NaOH, other products 2CO2 H2 NaOH. And you observe this one, during electrolysis a base is formed. That is why pH of solution increases. During electrolysis, pH of solution increases due to formation of sodium hydroxide. Now if you take this example, what is the intermediate formed? Ethyl free radical is the intermediate formed. Ethyl free radical. So when 2 free radicals combine with each other, CH3CH2 CH3, then we get a direct product. Apart from this, there are some minor products, that is one hydrogen from this is transferred to this one. If there is a hydrogen free radical shift, let H free radical shift, then here it is losing one hydrogen. So what is formed? A double bond is formed here, and this is gaining one hydrogen. So this is CH3CH3. So what are the other possible products? Ethylene, ethane. What is the major product? This is major product, butane. So here this is transfer of hydrogen, this is losing hydrogen and this is gaining hydrogen. That is why the same species is undergoing simultaneous oxidation and reduction. So, what is this reaction? This is a disproportionation reaction. Disproportionation reaction. Simultaneous oxidation and reduction by same species is called a disproportionation reaction. Now, apart from this, here what is the other free radical formed? CH3CH2 COO free radical. This free radical may combine with this ethyl free radical. This is a propanoate free radical and this one is a ethyl free radical. And these two free radicals may combine. Then what is the other possible product? CH3CH2COO C2H5. So, this is also formed in small amounts. So, if we take electrolysis of sodium propanoate, you may be asked a question, which of the following is not formed here? Which of the following is not formed? In one of the options, if you find methane, what are formed? One is butane, ethylene, ethane, and this one, what is the name of this one? Ethyl propanoate. So, these compounds are formed. Which is not formed? Methane is not formed, like this. We will see another example for this one. I am discussing only important examples, not all the examples. Okay, let this is sodium salt of carboxylic acid in aqueous solution, electrolysis. This is a sodium cyclobutane carboxylate. Then you assume what is formed here? A free radical is formed. This is the free radical. Then after formation of this free radical, it combines with another free radical. So, what is the compound formed? This is cyclobutane. Cyclobutyl cyclobutane. You can see what are the other possible products. What is the free radical formed here? Cyclobutyl free radical is formed. So, from this by transfer of hydrogen from one free radical to another free radical, this is formed, plus this is also formed. Then what is the carboxylate ion? This is the carboxylate ion. It may combine with this one to give these products also. This one, like this we want to see. Another example we will see. This is example. What is this name of this compound? Sodium cyclobutane carboxylate. Now we will take another example. Not this one. CONA. So, what is the intermediate to be assumed here during electrolysis? A free radical. So, by removing this CONA, you take one electron here. By removing this one, you take one electron here. So, between these two, a bond is formed. Then what is the compound formed? cyclohexene is formed. Like this you have to see compounds formed in Kolb's electrolysis. Then we will see another important reaction in hydrocarbons, that is Wood's reaction. By reaction of alkyl halides with sodium in presence of dry ether, symmetrical alkanes are formed. That is Wood's reaction. So you can write a general equation like this: alkyl halide with sodium in presence of dry ether, then we will get RR plus NaX. This is. Now if we take mechanism of this one, this also takes place through formation of free radicals. So Rx, from sodium one electron is given to this one, so it becomes R free radical X minus and Na plus. Then these alkyl free radicals combine with each other to form this one. Now if we take reactivity order of this is important. What is the reactivity order of different alkyl halides in Wood's reaction? Alkyl iodides are more reactive than bromides than that of chlorides. Then tertiary greater than secondary greater than primary, but exceptional is tertiary alkyl halides in Wood's reaction give alkenes, means they undergo dehydrohalogenation, removal of halogen and hydrogen, dehydrohalogenation. That is. Now we will see some examples how to write direct products in Wood's reaction, and also you have to remember which is formed, which is not formed in Wood's reaction by using different alkyl halides. Okay, I will take one example. If we take ethyl iodide in Wood's reaction, sodium dry ether, 2 moles you take, you break it here, combine these two parts, CH3 CH2 CH2 CH3. So this is butane. Methane is not prepared by this method because methane contains only one carbon. So here we will get hydrocarbons, that is alkanes containing more than one hydrogen. That okay. We will take another example. Say X is an alkyl halide. Alkyl halide on reaction with the sodium and dry ether, it is giving a compound like this hydrocarbon 1 2 3 4 5 6. Name of this is 2,5-dimethyl hexane. Now what is X? What is alkyl halide? Let here sodium iodide is formed, means this alkyl halide is iodide. Then how to find out this reactant? You break this alkane symmetrically, that is here you break, then add iodine to each broken carbon. So this is broken carbon, here I have to add iodine. So by adding iodine, so what is the compound formed? 1 2 3. So what is this X? 2-methyl 1-iodo propane, this one. Okay. Then we will take other examples. Let this is the compound, bromine here, chlorine here. Then on reaction with sodium and dry ether, what is the major product? A bicyclo compound is formed, this one, bicyclo compound. First you write a free radical formed from this here, here. Now these two electrons combine to form a bond here, that is why what is the product? A bicyclo compound is formed. Okay. So these are some important preparation methods of alkanes. Okay, ఎంత టైం ఉంది? ఓకే, now if you take tertiary alkyl halide, say tertiary butyl iodide, why it does not give an alkane in Wood's reaction, sodium and dry ether? So here what is formed? A free radical is formed. Suppose two such type of free radicals combine. Let this is one free radical, this is another free radical, then what do you get? This you get. Okay, but due to bulkiness there will be repulsions. That's why this compound is not formed here. Then here one hydrogen from this hydrogen electron, this combines with this one, this combines, and this hydrogen free radical comes out. So here what is formed? A double bond is formed plus hydrogen free radical. So what is formed here? This is isobutene. So tertiary butyl iodide gives isobutene, it does not give alkane. Then suppose if I take this reaction, CH2I, sodium and dry ether, you can write what is the product, you can check it. Then coming to some important preparation methods of alkenes. These are some important preparation methods in alkanes. Now we will see alkenes. Today I am discussing only preparation methods of hydrocarbons. Okay, we will take dehydrohalogenation. Dehydrohalogenation means removal of hydrogen halide, and this is an example of beta elimination. What is meant by beta elimination? Beta elimination means hydrogen and halogen are eliminated from adjacent carbons. Then it is called beta elimination. So what is this dehydrohalogenation? Removal of hydrogen halide. Then the reagent used for this dehydrohalogenation is called dehydrohalogenating agent. Dehydrohalogenating agent.
శ్రీ మహంకాళి జ్యోతిష్యాలయం సికింద్రాబాద్. ముఖం చూసి జ్యోతిష్యం చెప్పబడును. మేము కోయరాజులం. తాతల నాటి నుండి శ్రీ సమ్మక్క సారక్క కొండదేవతల పూజలు చేస్తూ ఉంటాం. అనుభవజ్ఞులైన కోయరాజు జి ధర్మరాజు గారు గత 33 సంవత్సరాలుగా సికింద్రాబాద్ లోనే స్థిరంగా ఉంటున్నారు. సెల్ 9005297753. ప్రేమ, పెళ్లి, సంతానం లేని వారికి, భార్యాభర్తల సమస్యలు, కోర్టు సమస్యలు, చదువు, ఉద్యోగం, వ్యాపారం, మనశ్శాంతి, లక్ష్మీ శాంతి, ఆరోగ్య శాంతి, చెడు ప్రయోగాల నివారణకు శాంతి చేయబడును. మరియు నరఘోష, నాగదోషం ఉన్న వారికి, ఇంకా ఎటువంటి గ్రహాలకైనా పూజలు చేసి యంత్రాలు ఇవ్వబడును. ఇంకా ప్రేమ వశీకరణ, ధన వశీకరణ, భార్యాభర్తల వశీకరణ, సంతాన వశీకరణ, వ్యాపార వశీకరణ, విద్యా వశీకరణ, ఆరోగ్య వశీకరణకు పూజలు చేయబడును. గ్రహపీడలు తొలగించబడును. ఏ సమస్య సమస్యలకైనా అంజనం వేసి చూసి చెప్పబడును. అన్ని రోగాలకు వనమూలికలతో వైద్యం చేయబడును. ఈ సృష్టిలో దైవశక్తి ఉన్నది ఎంత నిజమో దుష్ట శక్తులు ఉన్నవి కూడా అంతే నిజం. నమ్మకంతో రండి, ఆయురారోగ్యాలతో వర్ధిల్లండి. సర్వే జనా సుఖినో భవంతు. మా అడ్రస్ మౌండో మార్కెట్ వెనుక ఇందిరాగాంధీ బొమ్మ ప్రక్కన, సికింద్రాబాద్. సెల్ 9000529753. సంప్రదించు సమయం ఉదయం 9 గంటల నుండి సాయంత్రం 6 గంటల వరకు.
స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్. సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3:30 నుండి సాయంత్రం 5:30 వరకు, తిరిగి సాయంత్రం 6 గంటల నుంచి 7 గంటల వరకు మీ V3 న్యూస్ ఛానల్లో, V3 న్యూస్ యాప్లో, V3 న్యూస్ యూట్యూబ్లో ప్రసారం అవుతుంది. యూట్యూబ్లో V3 న్యూస్ ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి. అలాగే V3 న్యూస్ యాప్ను మీ మొబైల్స్లో ఇన్స్టాల్ చేసుకోండి. దశాబ్దాల అనుభవం గల ఫ్యాకల్టీలు అందించే క్లాసులను వినండి, సద్వినియోగం చేసుకోండి, విజేతలు కండి. ఫ్యాకల్టీల వివరాలు: మ్యాథ్స్ బాదం శ్రీనివాస్, కెమిస్ట్రీ రవీంద్రనాథ్, ఫిజిక్స్ ఆసిఫ్, బాటనీ మిట్టపల్లి రామ్నాథ్, జువాలజీ సిహెచ్ కొండలరావు. V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్.
మీరు సొంత స్థలంలో ఇంటిని నిర్మించాలనుకుంటున్నారా? 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. అవునండి, మీరు విన్నది నిజమే. సన్షైన్ ఇన్ఫ్రాలో 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. టాప్ మోస్ట్ ఇంజనీర్స్, ఆర్కిటెక్ట్స్, మేస్త్రీల ఆధ్వర్యంలో ఇక నిశ్చింతగా మీ సొంత ఇంటిని కట్టుకోండి. సన్షైన్ ఇన్ఫ్రా బిల్డర్స్ అండ్ డెవలపర్స్.
శ్రీ సమ్మక్క సారక్క జ్యోతిష్యాలయం, కోయ పూజారి ఏ రామరాజు. మేము కోయరాజులం. మేము తరతరాల నుంచి ముఖం, హస్తరేఖలు